Today we have an exciting topic in the science and space category. Have you ever wondered what connects the storms on Jupiter to the oceans on Earth? Let's dive into the fascinating discoveries made by scientists who have uncovered these links. Let's get started. It all began in 2018 when scientist Leah Siegelman noticed a striking similarity between images of Jupiter's massive cyclones and the ocean turbulence she was studying. To physicists, both air and water are considered fluids, so applying ocean physics to Jupiter isn't as far-fetched as it sounds. Jupiter is basically an ocean of gas, said Siegelman. This observation led Siegelman to co-author a groundbreaking study published in 2022 in Nature Physics. The study analyzed high-resolution infrared images of Jupiter's cyclones taken by NASA's Juno spacecraft. The analysis revealed that convection, similar to that seen on Earth, helps maintain Jupiter's storms, which can be thousands of miles wide and last for years. While focusing on Jupiter's cyclones, Siegelman also noticed wispy tendrils, known as filaments, in the spaces between the gassy vortices. She decided to investigate further, using Juno's detailed imagery to study whether this resemblance to Earth's processes was more than skin deep. In her follow-up study published in Nature Physics, Siegelman found additional similarities between the processes fueling Jupiter's cyclones and those on Earth. The study showed that the filaments between Jupiter's cyclones work with convection to sustain the planet's giant storms. Jupiter's filaments act similarly to fronts on Earth. To understand the role of the filaments between Jupiter's cyclones, Siegelman analyzed a series of infrared images from Juno. These images, taken in 30-second intervals, were of Jupiter's north polar region. The infrared images allowed Siegelman and her co-author, Patrice Klein, to calculate temperatures. Bright areas were warmer and dark areas were cooler. Hotter parts correspond to thin clouds, and cooler parts indicate thick cloud cover. They tracked the movement of clouds and filaments to calculate horizontal wind speeds. With this data, Siegelman and Klein applied ocean and atmospheric science methods to calculate vertical wind speeds based on the temperatures and horizontal wind speeds. They discovered that Jupiter's filaments behaved like fronts on Earth. These vertical wind speeds at the edges of fronts on Jupiter indicated that the fronts played a significant role in transporting energy as heat from the planet's hot interior to its upper atmosphere, fueling the giant cyclones. Although convection is the main driver, the fronts account for a quarter of the total kinetic energy powering Jupiter's cyclones and 40% of the vertical heat transport. Siegelman said, "These cyclones on Jupiter's poles have persisted since they were first observed in 2016. The filaments between the large vortices are small, but crucial for sustaining the cyclones. It's fascinating that fronts and convection are influential on both Earth and Jupiter, suggesting these processes may exist on other turbulent fluid planets." Don't forget to subscribe and hit the notification bell. See you in the next video.